we're going to talk about codecs. It used to be that with film, you had a piece of celluloid with a lot of chemicals on it that would react to light. It would make a negative by making bright places dark and dark places bright, and then we could invert those values with another chemical process to get a positive, to get an image. And that is how every single frame recorded information. But nowadays we have digital camera. The cool thing about digital cameras is we can actually see what we're filming at the same time we're filming it. Nuts, right? Amazing. People won't want to give that up no matter how much you love the evolving chemical processes of film. Being able to see what you're doing as you're taking the picture, amazing. But the problem is the machine, it does not see what you're doing the same way that you see what you're doing. It has inside of it its own special chip. So it's got a chip inside of it that it sees the world it's looking at through. And just like the film, it's photosensitive. It reacts to light. But it reacts differently. Instead of creating a chemical change when light hits it, it actually records the amount of light that hit it and the color of light that hit it, and it does it in a grid. So it takes the information from a grid, the pixels are the individual information pieces on the grid, and it finds a way to convert that into numbers. So it takes an image, captures the image, and converts it into numbers on the other side. The problem is when it converts it to numbers, it doesn't do it in the way you think it does. Because the way you're imagining it's doing it is it grabs a perfect snapshot of the world and throws out all the information that it has. And very few cameras are actually doing this. If they are shooting in log or raw, that's as close as you can get to just getting a raw dump of the numbers that the camera saw when it looked at the world. But what most of the time happens is it creates what's called a capture codec, where it actually compresses the information. So there's a lot of little pieces of information that you don't necessarily see. Sometimes it's pieces of black that gets thrown away. Sometimes it takes two pieces and it says, well, those are similar. I'm just going to record one and say that it happens twice. There are lots and lots of ways that a codec can change how big a file is when it saves a snapshot. So it gives you a much more simplistic picture of what's happening with the image. But your eye can't tell, so it's usually good enough. But if you try and make a change to that later, it can cause problems. So that's a capture codec. Whatever you did to get the image off your monitor or to get the image off your camera is a capture codec. So let's talk about those. You now have a bunch of numbers, and you need to convert that back to an image. So here's your information. So very nice capture codecs, like RAW, often includes information that you can't see, that sits behind the information that's been captured. So this is a great way that if you're changing values, let's say you want to brighten something up, you might be able to pull out some information that you couldn't see beforehand if you want to make some of those changes. So a lot of times what a capture codec will do is it'll actually take the information that you can't see and it'll throw it away. It'll get rid of it right from the get-go. That means you have less information to play with if you want to try and find something in the image that wasn't there, like a color value or a light value that you don't directly see. It then has to kind of guess and move what it already has around and isn't able to pull some of that latent information out. So that's one problem with the capture codec. And in other times, capture codecs will do something very interesting too. They will get rid of duplicate information and they'll say, well, these 4 pixels right here are all blue. So we're just going to say that this 1 pixel in the middle is blue. So now we've got the whole thing recorded like this. This is the actual information here, but the codec itself says, hey, draw this block 4 times out right here instead of worrying about recording every little bit of information. So that can add up some real processing power behind it. So you can get these really tiny images because it throws away extra information. Because now we just have two blocks, right? We have a red block and a blue block. But the computer is told, hey, draw this one red block here, draw this blue block 4 times, and then take this red drop and draw it again over here. So we now created the same image, but it took a lot more processing power, it took a lot more moving around to make that image appear. So that's another limitation of a capture codec. That's why people often use editing codecs to edit with, because the last problem with the capture codec is probably the biggest one. Is a lot of capture codecs are what's called interframe codecs. So let's say you have a frame of video, and then a frame of video, and then a frame of video, and then a frame of video. These 4 frames of video aren't a lot of information, but as you know, you have millions of frames of video as you keep recording. So with these frames, every time you make a change, what you expect to happen is what happens in an intra-frame codec, or an editing codec, or in RAW. In an intra-frame codec, when you edit with that, you can actually take one frame out and change it to be another frame. This frame looks like this frame looks like this frame looks like this, and this frame looks like this. Nothing's confusing for the computer. But with the capture codec, since they're so worried about saving space, they're actually drawing only the changes. So now, if we have a capture codec and it looks like so, the capture codec really says, let's get rid of these and let's add this 4 times. And so as you add that same one 4 times, you might get a same image, but it's using less information to make that image. And it takes more processing power for your computer to do that. Well, that's a problem for editing. So now let's say we take one of these frames and we make it blue. Now it has to go back and read the changes from the first frame every time it makes a change again. So it has to say, okay, now here's all the information you need, and then as it draws it back, it's got to understand what changed and where, so it can rebuild everything because it looks at all the frames at the same time. It saves space, but it doesn't save processing power. The computer has to draw and imagine all those changes as they happen. So as you're layering things, as an editor, you start adding layers of video. These layers of video are usually not in the right codec for editing, and so you make changes to them. And then your computer has to remember all the frames and all the changes in all the frames for all the different codecs as they're being changed and layered and then blended together. And you can imagine how this gets hard and complicated for a computer. So that's why a lot of people use editing codecs. So editing codecs are 2 things. They are 1, compressionless. What compressionless means is a very nice thing. So we need to take a split second talk about compression versus compressionless. Earlier I was talking about removing blocks to save on information, that is a compression. If you save everything without compression, then that's compressionless. You can have compressionless interframe codecs, meaning you can have compressionless codecs that when it saves it, even if it saves it interframe, where it has to use the same information from earlier frames to redraw the frame, to redraw the image, even though if it's not an editing friendly codec, it's more of a capture codec, it can still be compressionless when you render it out. As long as you're not throwing away any more information, it's compressionless. So that's different than interframe versus intraframe. But a good edit codec, something like ProRes or Magic's intermediate codec or something like ProRes, they're called an edit codec or an intermediate codec because you can take a capture codec and you can actually redraw something as interframe. And that adds information, but it makes it nice and clean and easy for the editor to work with, and it does it in a way that doesn't throw away any information. In fact, it adds information back. So changing something, when you change a codec, it's called transcoding. So changing something from the capture codec that may have came directly from the camera, changing it to an intermediate codec is a way to say that maybe you've added information, but you've made it something that's easier for the edit to work with. Now, as we talked about earlier, though, you might have an issue where there's so much information and you have layers of information, and your computer, even though it's a nice clean codec to work with as far as how it has to remember and rebuild it, it's not an easy codec to work with as far as how big it is, because it's still got big, heavy pieces of data it has to move around, and a lot of that unnecessarily, because a lot of that data you're not even looking at or manipulating. So if you need to save space, this is where a proxy comes in. You can build a proxy for a lot of different kinds of codecs, but particularly if you do it for an edit codec, what you're doing is you're actually taking a more pixelated version of your original edit codec, and you're saying, I'm going to use this smaller version as a go-between to make all my changes. So then you use the smaller version and you make your changes, and then you say, great, I'm done editing, I'm done moving all this heavy data around. Then the computer rebuilds it without the proxy, where you get your nice, pretty data back the way you wanted it. So that's what a proxy does, is it gives you a smaller file to work with. It's different than an intermediate codec, because an intermediate codec can still be very large. Both have the goal of letting your NLE have an easier time editing. So if you use both together, that can be how you have the best experience while you're editing. The last piece of a codec is the delivery codec. And a lot of people are confused about this because they sometimes have similar names to capture codecs, sometimes they are capture codecs, and sometimes people don't know what's the best one to use. But the reality is a delivery codec is a capture codec for where your project is going to go. Is your project going to go to YouTube? Then what you need to do is have your project rendered out in a file that's ready for YouTube. So I've been avoiding using codec names, but I want you to understand that these names and things are just names for the processes and containers that are holding and moving and storing these informations. We're going to talk more about containers and codecs in a little while. But right now, without naming any names, you need to deliver your edit codec back into a file. So you can render your project, make it all nice, one sandwich product again. And if you did it in the edit codec you were editing in, or even the capture codec you were editing in, you're likely going to have a pretty picture of your image, and you're going to have it nice and together and ready to deliver. It's all one piece. You don't have to have the whole NLE file anymore. It's just a single file that can be clicked on and watched. It is now ready to deliver. But the thing is sometimes you need it really, really small. It might need to fit on a PowerPoint. Sometimes it needs to be really, really big. Like you need to make sure that it's big and has all the data saved. And so you give the intermediate codec as the delivery codec, because you want to make sure that an editor down the line later can grab the same one. That's an archive. It can grab the same older footage and use it again without having any lost pieces of information. We're still having depth in the footage. A lot of times what you need to do is just get a nice little snapshot of what you got, compress it a little bit, and when you compress it a little bit, then you got a smaller version of your video, and you can put that on the internet, and the internet can stream it. So it's in a way that can be read by the computer on a real-time basis. That's a streamable codec. These are all different things, and there's more to consider than these two. These are just examples of reasons why you don't just have a finished product, you have a delivery codec. And you pick a delivery codec based off where it's going to go and the kinds of things those numbers have to do later. Do they need to take up a small amount of space? Do they need to be streamable? Do they need to run on any computer, or can it only run on a specialized program? All these things are something to consider. Now, the one thing people forget about delivery codecs is, let's say we make a compression. And so we have a nice, pretty finished product. We do a little compression where we save some space, and now we have another video, and it's pretty, and it can be redrawn again in a very pretty way that still looks good on its delivery format. And then they take that delivery format, they yank it back, and they take it and then they decompose it some more. And they get rid of even more information because they render it out again, they transcode it again, and they compress it again, and now it's smaller and it has less information, and then it doesn't rebuild quite as nicely as it did before. And then someone takes it and then they remove some more information. And then they say, now I have an even smaller version of the video. Or I've taken the same video and I've captured it off my monitor and put it back here. And then you have a video that just isn't going to rebuild the same way it did. That is loss of data, and that can happen if you're using delivery codecs when you're supposed to be using an intermediate codecs. If you're archiving with the delivery codec, if you're taking something very small and compressed and you're trying to open it back up again to edit and then deliver it again, you're going to start losing information and having all sorts of issues. These issues are pixelation, loss of color, weird colors or noises, little grains where there's not supposed to be grain. As the video editor has to get more and more, as the codec has to get more and more inventive on how to rebuild this data that you've lost. So that is capture, intermediate, and delivery codecs and how they're ideally used. Something to note, a lot of times what happens is you have a capture codec. It captures a nice pretty picture. It's compressed. You give it to your editor. Your editing codec, it says, let's move some things around, but it deals with the compression. It does a pretty good job about dealing and working with the compression anyway, because computers are getting pretty great. And so it edits around the compression, and then you have a new product, and so you've skipped the intermediate codec altogether. You just use your capture codec to edit with. This is very common, most common thing people do is just grab an MP4, edit with their MP4, and then they deliver as an MP4. So here's where the big problem is so if you have a codec that's already compressed, and then you've edited it already compressed, and then you render it out again. If you render it out as an MP4, it's looking for same piece of information. So if you render it out as the same codec you've been using all along, if you're not changing anything, it'll look at it and it'll say, yeah, I get it. The information I'm looking for, it's here. The information I'm not looking for, it's not there. It's not going to make much changes, a little bit, but it's not going to make a lot of changes to your video. So these changes can be moved and still delivered in a way that still looks pretty sharp and pretty good. This is how most people do editing, especially for YouTube. They capture as an MP4, edit as an MP4, and then deliver as an MP4. And as long as you're not changing a style of compression and a style of rendering, then you're very likely, even though you're not using some of the best practices, and even though you're not using some of the best information saving bits, what you are doing when you keep with the same codec, you're not asking more of the codec than it already has. It's a very easy, simple way to not pollute your data. But a bad workflow is if you take your information off your camera, you bring it into your editor, and when you bring it into your editor, you go ahead and compress it. This would be very bad. So then you compress it when you bring it into your editor. A lot of people take Handbrake, they destroy their footage with Handbrake, but it still looks kind of good. And then they have to render it out again. And then they ask it to change to a different codec. So they've taken their footage, they've lost some information already, it still looks kind of good though, and then they change it to another codec, and that codec has to rebuild things in a way that it wasn't expecting to do it, because you're now changing the language. You're changing how it was expecting to keep a pretty picture, and you're asking it to make a pretty picture in a different way. And a lot of times it's not able to do it because it's already missing lots of its information, especially when it's trying to pull information on places that it wasn't expecting to have to save it for and things like that. So as it uses a different math, a different method, then you get a pixelated piece of garbage, and then people send that out as a delivery codec. YouTube messes with it one last time, and then everybody says, why does my video look like crap? Now you know.